Good morning to another session. Today we'll be continuing our discussion on Laplace transform. This is the second part of our Laplace transform. So on the last day I gave you a problem as homework. Let's start with that problem. Okay, so this was the problem. Have you done it? Consider the differential equation given by this, where f of t is the inverse Laplace transform of this expression. If C1 and C2 are arbitrary constant, then general solution of this differential equation will be. Good morning, Rani. Have you done this problem? Simple problem actually. Look, what we have to find out first, this is the inverse Laplace transform of f of t is the inverse Laplace transform of this expression. So first of all you need to find out f of t, and then we can solve the differential equation. Look, Sunday test solution all of you have understood, no issue in that. After looking at the solution, what do you think? Were the questions really very difficult, or they were doable? They were doable from whatever we studied in the lecture. What do you say? Was it anything out of the syllabus or out of anything which we did not study? It is just you need to understand the things very well, or your actual exam purpose also. If your concept is clear, whatever question, however difficult question are set, you will be able to do that if you practice sufficiently. Okay, na? Practice is important, otherwise you will not develop that numerical solving ability. Let's go for this problem. So what is given? Given d square y by dt square minus 4y is equals to f of t, where this f of t equals to Laplace inverse of 1 by s plus 2 plus 1 by s minus 2. Okay, this equation you need to solve. What you can do? First of all, you can find out f of t. Laplace inverse of 1 by s plus 2, Laplace inverse of 1 by s minus 2. So s plus 2 will give you e to the power minus at, so minus 2t, and this will give you e to the power plus at, so plus 2t. Okay, no issue in this. So therefore you need to just solve this simple differential equation. What is this? This is nothing but second order non-homogeneous differential equation. Deep, Murli, those guys are not coming. Ajay, okay, so this is a second order non-homogeneous differential equation. So what we need to find out? We need to find out the complementary function and the particular integral. Let's calculate the complementary function first. What will be the complementary function? M square minus 4. First of all, characteristic equation we have to write. M square minus 4 equals to 0. M is equals to plus minus 2. So the complementary function becomes c1 e to the power 2t, c2 e to the power minus 2t. Okay. Moreover, we need to find out the particular integral. What is the particular integral? Pi equals to, this is d square minus 4, so 1 upon d square minus 4 into f of t e to the power 2t plus e to the power minus 2t. Now let's just separate them. 1 by d square minus 4 e to the power 2t plus 1 upon d square minus 4 e to the power minus 2t. Let me know if at any step if you find it confusing or any question. If you have, you can let me know. Now for the first term, as you can see, if you put, you need to put d equals to a, right? A is 2 here and here a is minus 2. So what is happening here? If you put d is equals to a, this denominator is 0, so you have to multiply with t and you have to take derivative of the denominator with respect to d. So d square minus 4 derivative will be 2d, so 1 upon 2d e to the power 2t. Same goes here, 1 upon 2d, because d equals to minus 2, if you put d equals to minus 2 then also it becomes 0, so that is why t should be multiplied. Can you write it? And hence this becomes t by 2 1 by d times e to the power 2t. So what does it mean? It means e to the power 2t dt plus t by 2 e to the power minus 2t dt. Remember this thing, I think you know it. D is equals to d dx, d square dx square, and 1 by d corresponds to integration. So this becomes t e to the power 2t divided by 4 and minus t e to the power minus 2t by 4, and hence the general solution becomes sum of complementary function plus the particular integral. So c1 e to the power 2t plus c2 e to the power minus 2t plus t by 4 e to the power 2t minus e to the power minus 2t. Now you can match it with the given options by taking let's say the coefficients of e to the power tt, e to the power 2t. So you see here it is c1 and plus t by 4 e to the power 2t and plus c2 minus t by 4 e to the power minus 2t. That is matching with option B. Its rule to multiply t. Yes, we did not say this particular integral rules, we gave you the rules. Just go through them once. We gave you for this e to the power ax, particular integral is equals to 1 by f of d e to the power ax. Okay, this is equals to 1 by f of a e to the power x if f of a becomes 0, so 1 by f prime a if f of a is equals to 0, f prime a not equals to 0, and if f prime a also 0, another x will be multiplied. Do you remember or not? You can check the rules for particular integrals. Whenever the denominator will be 0, x will be multiplied, and after multiplying x also, if this denominator becomes 0, then you have to take in differentiation again, and it will be x will become x square. Good morning, Murli. Okay, Harry. So everything is understood. Let's go for another problem. Look, as I told you that sometimes in the question paper you may not be asked to directly calculate the Laplace transform, but you may be given a very special type of integration where you can use the concept of Laplace transform. So this is such a problem here, just asking you that what is the value of this integration. But as you can see, if you carefully look at, it is like this is the function f of t, and this is this e to the power minus st with s is equals to 2, and 0 to infinity. This becomes calculating the Laplace transform of 1 minus cos 3t, and at the end you will put s equals to 2. Same goes for here. It is like this is your f of t, right, and this is your e to the power minus st with s is equals to root 3. So it is necessarily means Laplace transform of f of t by t. This formula we have already told you. So two problems, two integration, two Laplace transform have been multiplied. So do this, a very good problem. So let's call this integration. Okay, you also try. I am doing this along with you. I equals to 0 to infinity e to the power minus 2t 1 minus cos 3t dt multiplied by 0 to infinity e to the power minus t root 3 sin 2t cos t by t. So let's call this as the product of I1 and I2. So we will calculate I1, I2 separately, I1, I2, where I1 is the first term, I2 is the second term. So I1 0 to infinity e to the power minus 2t 1 minus cos 3t dt. So Laplace transform of 1 minus cos 3t, Laplace transform of 1 minus Laplace transform of cos 3t, 1 by s, cos means s will come, s by s square plus 3 square, okay. So therefore lap 0 to infinity e to the power minus 2t 1 minus cos 3t is equals to 1 by s minus s by s square plus 9 for the value of s is equals to 2. So 1 upon 2 minus 2 by 2 square plus 9. So 2 by 13, 26, 13 minus 4, 9 by 26. You got the first integral 9 by 26, all of you? Let's go for the second integral. I2 0 to infinity e to the power minus t root 3 sin 2t cos t divided by t, then dt was missing here, okay, dt has been taken here. No, another dt you can, we missed dt here. So let's calculate the Laplace transform for this function sin 2t cos t by t. So first of all we need to calculate the Laplace transform of sin 2t cos t, because in the formula of f of t by t you need the Laplace transform of f of t. So this is if I multiply with 2 and divide it by 2, then we get a formula of 2 sin a cos b. 2 sin a cos b means sin of a plus b plus sin of a minus b, and this becomes half times L of sin 3t. So sin means a will come 3 by s square plus 3 square plus a by s square plus a square. And look, we know the formula that Laplace transform of f of t by t. What is the value? S to infinity f bar s ds. So we can say that the Laplace transform of sin 2t cos t by t will be s to infinity integration of this thing, half taking aside 3 by s square plus 9 plus 1 by s square plus 1 ds. So this form of integration, you know, it's like 1 by a square plus x square dx in that form. So the formula is 1 by a tan inverse x by a. One by a tan inverse x by a. This is the formula from class 12. Look how much class 12 is important. You will be seeing throughout the mathematical methods while doing differentiation, integration. Your CSIR-NET exam requires your preparation from plus 2 levels. Now, if your plus 2 is not completely strong, you will stuck at many steps. Now, before taking physics honors, I was very much interested in mathematics. I had a teacher in my class 12 of mathematics. He was a very brilliant teacher, and what I liked most about him, whatever I used to ask him, he used to answer. Not only me, any student, whatever silly questions students used to ask, the teacher used to answer it very politely. Even if you ask, let's say, how 1 plus 1 is 2, this kind of thing, I am just for example, the teacher used to answer it very politely and in a very good way. So at that time I used to take tuition for mathematics. At that time I loved this subject very much. So initially I was thinking of taking mathematics honors, but later I got interest in physics, so I came in physics. But while pursuing physics also, you know, mathematics is always there. So mathematics is one of my most favorite subjects other than physics. So I think many of you also have the same story. Okay. So if you put tan inverse s equals to infinity, so what will be the first term? Tan inverse infinity. Second term tan inverse infinity. Now put s equals to s, so minus tan inverse s by 3 minus tan inverse s. So what is this value? Tan inverse infinity means pi by 2 minus, okay, let's put the value later on, because here we need to put the value of s also. Therefore the integration value 0 to infinity e to the power minus t root 3 sin 2t cos t by t. This was the integration, na? So this will become, you have to put s is equals to root 3, so minus tan inverse 1 by root 3, that is pi by 6, tan inverse root 3, so pi by 3. If you calculate this expression, what you get? Pi by 2 pi minus pi by 6 minus pi by 3 by 2, so you will get pi by 4, yeah? And hence the final answer, you can say 0 to infinity e to the power minus 2t 1 minus cos 3t dt times 0 to infinity e to the power minus root 3t by t sin 2t t cos t dt. First term we got 9/26, second term pi/4. So this becomes 9 pi/104. That is matching with option B. Understood? Now let us try to discuss a very important thing. I think from the Laplace transform, the basic thing we have already covered. Now let's go for little unusual, na? But questions may come. Laplace transform of unit step function. Unit step function is also called Heaviside function. Unit step, the name speaks for itself. The name itself giving you the definition. Step with unit height, that is the unit step, na? So let's say you have a function which is defined in this way. This is u t minus a versus t. U t minus a means when t is equals to a. Before t is equals to a, the value of the function will be 0, and as you cross t equals to a, the value is 1, and it will go up to infinity. So mathematically u t of t minus a, this is a unit step function, this is 1. So you can see it is looking like a step or staircase of unit height. So this is equals to 0 for t less than a. This is equals to 1 for t greater equals to a. This is the definition of unit step function. And this, sometimes we just write the reference point as the subscript. What do I mean? U t minus a, this is sometimes also represented as u, the reference point as the subscript. So u a of t, these are same nomenclature. Let's say for example, if you have u, let's say t minus 3, what does it mean? Beyond t equals to 3, the function will take up the unit value. So we can express it like u 3 of t. Okay. Now the question is, what is the Laplace transform of this unit step function? So if you do not know, just use the original formula, main formula. So 0 to infinity e to the power minus st ft dt. So ft is u t minus a dt. Okay. So what will be this? Look, it is taking value between 0 to a, it is 0. So you have to take a to infinity, e to the power minus st, the value of ut minus a is 1. So what do you get? E to the power minus st by minus s, a to infinity. So this is e to the power minus as by s. So the Laplace transform of u t minus a is equals to e to the power minus as by s. Laplace transform of u t minus a is equals to e to the power minus as by s. And similarly, Laplace transform of f of t minus a, u t minus a will be, what do you expect? F of t minus a, u t or minus a, when this unit step function is multiplied with the other function f of t minus a. So this will be, because of this u t minus a, e to the power minus as will come, e to the power minus as will come, and f bar s, where f bar s is the Laplace transform of f of t. Now to give you more idea on this unit step function, how it works, let's just plot a very special graph. Let us try to plot k times u t minus 1 minus 2u times t minus 4 plus u times t minus 6. Look, this is very simple thing, but you need to understand little bit carefully. The meaning is, beyond this reference point, the value will be 1 till infinity. Okay. So let's say this is your function. So we can also express it in this way: k times u t minus 1, so u1 of t, minus 2 u t minus 4, so u4 of t, plus u6 of t. So this is what you need to plot. So let's plot this. Okay. First of all, let's say this is your plus k, and this is the minus k. This is your t axis. Now notice carefully, u1t, what does it mean? Beyond t equals to 1, it should give you 1, right? So from 0 to t, the value is 0, and once it reaches t equals to 1, its value will be 1, like this. But here you see, t minus 2 times u4t means at t equals to 4, so it is 2, 3, 4, 2, 3, 4. So when t equals to 4 will be crossed, u4 of t will be 1. Okay, and this is inactive. u6 means you need to have up to 6, t equals to 6, then this function will be active, otherwise they are 0 na. Beyond t equals to a, on the left side, the value of the function is 0. So u1 of t will continue its value, of 1 because the other two terms is not activate. So it will go up to 4. So as soon as it reaches 4 and crosses 4, you see this value will be 1. So u1t is 1 minus 2, so minus 1, so minus k. No? So at t equals to 4, its value will be minus 4, sorry, minus k. Now it is continuing till t equals to 5 because u6 of t is not activated yet. So as it reaches to t equals to 6, the value of u of 6t is 1. So 1 minus 2 plus 1. So 2 minus 2. So 0. So it will be 0 again up to infinity. Just tell me whether you understand this or not. Very interesting thing. Simple also. Have you understood the concept of unit step function now? So for unit step function, you need to understand the unit step function, and other than that, you just need to remember these two formula. One is this, another one is this. That's it. How it continues up to 4. Okay, you see, if I show it here, u1 of t, its value is 0 for t less than 1 and it is 1 for t greater than 1. So t greater than 1, so t from 1 to infinity it will take up 1, right? So k times, you see, u1 of t minus 2 times u4 of t plus u6 of t. So for u4 of t, it is 0 till t less than 4 and it is 1 for t greater than 4, and u6 of t, it is 0 till t equals to 6 and it is 1 for t greater than 6, है ना? So up to t equals to 4, it is 0, it is 0. So if you put 0 here, if you put 0 here, so what you are left with? Only u1t, है ना? So 1 will be written. And that is why it is taking up the value of 1 till t equals to 4. Now when it is t greater than 4, it also includes t greater than 1, na? So this u1 t1 value will be retained, and now beyond t greater than 4 this value becomes 1, but this value becomes 0 again. So 1 minus 2 is minus 1, so minus k is multiplied. So that is why this becomes minus k at t equals to 4. Then t equals to 5, at t equals to 5 also these two functions survive, and as soon as t greater than 6, t greater than 6 includes t greater than 1, t greater than 4 also. So this will be 1, this value will be 1, this value will also be 1. So 1 minus 2 plus 1. So this is 0, na? That is why beyond t greater than 6 it is 0. Is it clear now? Look, in the definition of unit step function I have shown you this, but this continuing up to infinity, na, along the t direction, it is continuing up to t tends to infinity, na? It will continue taking one value up to infinity. Clear now everyone? It's a very good concept. If you understand this concept, the upcoming things will be very easy for you. Let me give you a problem based on this simple problem. Just look at it. A periodic square wave function f of x in terms of unit step function can be written as k times u0x minus 2 u0x plus 2u2 and so on. Calculate the Laplace transform of f of x. Can you do this? अच्छा, सो यहाँ पे भी आप लिख सकते हो Laplace transform of u a of t सेम रिप्रेजेंटेशन, यहाँ पे भी आप लिख सकते हो Laplace transform of f of t minus a u a of t e to the power minus as f bar s. Same thing we have written, just written with this nomenclature. Now do this. Look at this problem. Laplace transform of f of x will be equals to k times Laplace transform of u0x minus 2 times Laplace transform of ux plus 2 times Laplace transform of u2a of x 2 times Laplace transform of u3a of x and so on. This is equals to, look, for all this term 1 by s will come, e to the power minus as by s, that is the formula. So let's take that as common, or let's do another step, 1 by s minus 2 times e to the power minus as by s, 2 times e to the power minus 2as by s, 2 times e to the power minus 3as by s and so on. No issue in this. Let's take k by s common. K is already common, so 1 by s is taken common. 1 minus 2, as you can see, we can take e to the power minus s common here, So 1 plus e to the power minus s minus will be there, no? Plus e to the power minus 2s minus e to the power minus 3s plus. Can I write it in this way? So this is the formula, no? Alternate sign. So 1 by 1 plus x formula. It's like 1 minus x plus x square minus x cube. You know, when all the terms are positive, you get 1 by 1 minus x. So there are alternate signs. So 1 by 1 plus x formula. I hope this one is understood. One plus e to the power minus s minus 2 to the power is, so 1 minus e to the power minus s by 1 plus e to the power minus s. K by s, we can take e to the power s by 2 common once again, e to the power minus s by 2 if you take common, denominator will give you e to the power s by 2 minus e to the power minus s by 2. Here also if you take e to the power minus s by 2 common, e to the power s by 2 plus e to the power minus s by 2. K by s, this is tan hyperbolic, no? Tan hyperbolic s by 2. So that is matching with option B. K by s tan hyperbolic s by 2. Was it difficult? Tell me. Provided that you know the formula, do you find it difficult? I hope not. Let me know once it is done, then we will go for some other formula. Convolution theorem is there. Did I tell you about Laplace transform of Dirac delta function? Can you calculate the Laplace transform for Dirac delta function? Simple है, Laplace transform of Dirac delta function. Laplace transform of, let's say, delta x minus a. So what will be the value? 0 to infinity e to the power minus sx fx dx. So from the property of Dirac delta function, you know, f of x delta x minus a dx equals to f of a. So e to the power minus s a. Now in case of Fourier transform also we define this term convolution. Convolution of two functions. Do you remember? we define this convolution of two functions. How do we define mathematically? Let's say if we have a function f of t and g of t, then the convolution of two functions, let's say f of t and g of t, is given by, it is represented by f star g, so function of t. We can write it as 0 to t f of u g of t minus u du. If you remember, we gave you the formula f of x prime g of x minus x prime dx prime. Na? This is the definition of convolution of two functions. Now, convolution theorem for Laplace transform, what is that? Convolution theorem for Laplace transform. So the statement is the inverse Laplace transform of a product of two Laplace transformed function is equal to the convolution of those two functions. The convolution theorem for Fourier transform is important, but this convolution theorem for Laplace transform is more important. The inverse Laplace transform of a product of two Laplace transform functions is equal to the convolution of those two functions. So, if Laplace inverse of, let us say, f bar s is equals to f of t, and Laplace inverse of g bar s is g of t, then inverse Laplace transform of a product of two Laplace transform functions. Inverse Laplace transform of product means f bar s times g bar s. This is a product of two Laplace transformed function is equals to the convolution of those two functions. So f star g of t, that is equals to 0 to t f of u g of t minus u t. So this is the mathematical form of this convolution theorem for Laplace transform. Let us take a very special problem if you are done with this. Try solving this problem. Let f of x of t be the solution of the differential equation given by this. subjected to the initial condition x at t equals to 0 equals to 0 and x prime at t equals to 0 equals to 1. If u t minus a denotes the unit step function, then which of the following option is correct? Very good problem. Give it a try, think about it. It's not difficult question. Take Laplace transform on both sides of the differential equation, है ना? Are you able to do this problem? Look, first of all, we need to take Laplace transform on both sides of the equation. So, taking Laplace transform on both sides of the given equation. We get, so Laplace transform of x double prime of t plus Laplace transform of x Laplace transform of delta t minus 1. So, it will be s square Laplace transform of x of t, so x of s, let us say, minus s time x of 0. Try to differentiate between small x and capital X. Small x is the function, capital X is the Laplace transform of x. So, Laplace transform of xt is xs. Okay, remember this one. minus x prime of 0. Can you write it? This is coming from the first term, and from the second term, Laplace transform of x is x of s. Laplace transform of delta t minus 1 e to the power minus as, so e to the power minus s, a equals to 1. Now what is given? That x equals to 0 at t equals to 0, and x prime is also equals to x prime is equals to 1 at t equals to 0, na? Yes. So what you are left with? X 0 0 you put x prime 0 equals to 1. So what do you get? S square and plus 1 x of s, and this minus x prime 0 is becoming plus 1 on the right hand side, plus e to the power minus s, this one. From this we can get the value of the Laplace transform of x of t. It is 1 plus e to the power minus s divided by 1 plus s square. But the sad part is answer is given in cos t sin t and unit step function. No problem, let's simplify the calculation. Sometimes it happens that we solve 70-80% of the solution correctly, and the remaining 20% we cannot do because we do not know the concept entirely clearly. Now from this, can you calculate x of t? It is asking you the value for the values of x of t. So x of t is the inverse Laplace of x of s, na? Therefore x of t, which is inverse Laplace transform of x of s, what you can write? Laplace inverse of 1 by 1 plus s square plus Laplace inverse e to the power minus s by 1 plus s square. Now you know what is the inverse Laplace transform of 1 by 1 plus s square. It is sin t plus, you see, it is in the form of e to the power minus s times f bar s. Look at this. What was the formula? E to the power minus s times f bar s. How do you write the inverse Fourier transform? Inverse Laplace transform of e to the power minus as f bar s will be this f of t minus a u t minus a. So a is here 1, and f bar s. Okay, let's show this calculation here. Here you see f bar s is 1 by 1 plus s square, means sin t. So what you get? U f of u t minus a, so a equals to 1 f of, look, the inverse Fourier inverse Laplace transform बार Fourier क्यों बोल रहा हूँ, of f bar s here is equals to sin t, but you have to put f of t minus a, so sin of t minus 1, matching with option B. Do you understand this last line or not? Tell me guys, the last line is very crucial, if you have understood the last line or not. Here we have used this formula inverse Laplace transform of e to the power minus s f bar s is equals to u of t minus a multiplied by f of t minus a. So the concept is essentially very simple, but the concept is little unusual. Unusual in the sense unpopular here. Now a very special problem related to a special function is there. Can you calculate the Laplace transform of Bessel function of 0th order? Look at this problem. The Laplace transform of the Bessel functions of 0th order J0x is. Acha, should I give you this problem as homework? You need to think little bit for this problem. So you take time and try to do it at home. Just note down the problem and this formula. This is a binomial expansion. Na? Just note down the formula. Let me know once it is done, then we'll go for the next problem. You will do it at home. Noted down the formula also. This formula you have to you will be required to use. Look, taking the Laplace transform is easy, but putting it into a compact form will be little bit complicated. That you have to do with the help of this binomial expansion formula. So we will try this at home. Let's go for problems. Okay, few problems are left. Try doing this. The Laplace transform of f of t equals to sin pi t is f of s equals to this. Laplace transform of t sin pi t each. Quick, now I think you can do this. A, B, C, D. Which option you are getting? Options are very close. Which formula are you using here? Laplace transform of x to the power n f of x minus 1 to the power n nth derivative of f of s f bar s, है ना? Are you not using this formula? Laplace transform of t to the power n f of t minus 1 to the power n nth derivative of f bar s. This formula I think will be used here. Tell me the option, correct option. दीप सी बोल रहे हो? सी, very good. Let's see if it is giving you C. So f of t is equals to sin pi t. So f bar of s Laplace transform of sin pi t, so pi by s square plus pi square. Okay, so Laplace transform of t sin pi t equals to minus 1 to the power n is 1 d ds of Laplace transform of sin pi t, that is pi by s square plus pi square. Yes, Harry, C. So minus 1 minus will come from the differentiation, so 2 pi s by s square plus pi square, and from differentiation square will be coming. So this is matching with option C. One last question, then we'll wrap up the session, and from the next day we'll start something else. I think on the next day we have to start complex, na? Which of the following pairs of the given function f of t and its Laplace transform f of s is not correct? Not correct. Okay, do this quickly, simple hai ye, you can do it in few seconds. Not correct, that you have to find out. Ajay Murli, yes, option C. For this, will you get back option C or some other options you would like to go? F of t equals to delta t, Laplace transform of Dirac delta, Laplace transform of 1, Laplace transform of sin kt, Laplace transform of t to the power kt. C, Deep again going for C. C is not correct. Okay, the first one is correct. You okay, Laplace transform of delta t is 1 0 to infinity e to the power minus st delta t dt. So this is e to the power minus s times 0, so e to the power 0 is 1. So pehla statement is correct. What about the second? Laplace transform of 1 is equals to 1 by s, that is also correct. Laplace transform of sin kt, Laplace transform of sin kt is k by s square plus k square, but it is giving you s by s square plus square. This is incorrect statement, correct option. For this t to the power kt, Laplace transform of t, so 1 by s square na, Laplace transform of t is 1 by s square, Laplace transform of e to the power kt times t, so this will make s to s minus k. So this is also correct. So option C. Yes, Harry. So with this we complete Laplace transform. I hope you are now in a good position for Laplace transform as far as Laplace transform is concerned. We'll be sharing with you maybe some more problems. So now let's talk about what should be our syllabus for the next Sunday test. Do you want to give any idea or anything you have to say about the syllabus for Sunday test 2? Let's discuss syllabus for Sunday test 2. Tell me what you want into your syllabus. We have done dimension analysis, vector and matrix. So what we can do in the next? Differential equation. Okay, differential equation, Dirac delta, coordinate system, Fourier series, Fourier transform, okay, let's take up to Fourier series na. Fourier transform, Laplace transform we can do in the next Sunday. This much will be okay. Differential equation, Dirac delta, coordinate and Fourier transform, Fourier series. Main question will come from differential equation and Fourier series, maybe few questions, and Dirac delta, coordinate, maybe one questions or something like that. Is this syllabus okay for you, or you want me to reduce the syllabus? It's okay, huh? That is okay, actually not too much. So revise it. Tomorrow morning we will be starting complex, and by the timing, whatever time you get, you revise. So this Sunday test will automatically help you to revise and give test. Okay, let me tell you, even if you get very less marks, that doesn't matter. We are here to improve our preparation. Even if you get, let's say, 4-5 marks, 1 or 2 questions get to be correct, that doesn't matter. You have to constantly improve. We have few months left for our examination, so we'll try our best to standardize our preparation. So make a habit of giving a test, and that is why we are taking the Sunday test on a very specific time of 9:30 na? Because on the final day exam you will be having your exam maybe in the morning at 9:30 or maybe in the afternoon session maybe from 2 p.m. So we are making a practice of giving the test in the morning. Although it is available, it remains available till the expiry of the test series date, but you should give the Sunday test strictly on the assigned time, 9:30 am. That will give you best result, and give it like real exam. That will improve all your instinct, that will improve your mentality also. In your examination you will not feel nervous, you will not feel extra pressure, you will be so much habituated in handling pressures. So with this note, let us end the session here today. On the next day we will start maybe complex analysis. Thank you very much, guys. If you are new to this channel, please subscribe the channel. All of you subscribe the channel and like the video. Bye bye, take care.